Hi folks, Paul here with another random repair. A friend of mine has just bought themselves an Creality Ender 3 3D printer, which comes as a kit set that you have to build up, and he started building it last night with his son, who's super keen to get into the 3D printing revolution. And there's a very disconcerting component loose in here, and looking through the grill, I think it's one of the large inductors that's come out. So his choices are: one is give it to me and have me try and fix it today or this morning so that he can get on and build it. The other option is to use a computer power supply. This is 24 volts apparently, 24 volts. Try and use a computer power supply. I might have a 24 volt server power supply floating around somewhere. And then the third option would be to send it back to China and wait for a replacement. But that would take longer than the remaining school holidays, and that would be just too frustrating. So let's open this up. I've got a Creality CR10 Mini, which is working fine and it didn't have any problems. So this is not typical, but can happen with cheap stuff. You get something that's not soldered down properly. So let's rip this open and see what happens. First of all, I need an Allen key of about that. Yes. This will be metric Allen key. Not sure what it is, what size it is. Yeah, I'll get myself a little box that I can put things in so I don't lose them. Okay, let's zoom out a little bit. Alright, so that's fine. Alright, next up, these ones here. So I'm about to break the seal. If I was really clever, I'd peel that back without breaking it. But it feels like it's an inductor. Now I'm guessing that I can solder that back in and all will be well. We shall see. So I'm just going to break that. Okay, here we go. Now we've got the fan. Do I need to remove the fan? I do actually need to cut that. And whoops, two more. Right, okay. So there's your problem, and I'm assuming it goes right there. So, can I unplug this? Yes I can, that's good. Okay. Yeah, there's an label L1, and L is usually inductor. So I'm going to have to unscrew the PCB and unscrew all the heat sinks, which is a bit of a drag. It's the heat sinks that are the most annoying thing to get back reassemble, because I've got to try not to lose this piece here. Oh, it's nicely, they used Loctite to seal it in. That was nice of them. So normally on these kind of power supplies they'll use a bit of this goop, this white goop, to hold the inductor in, specifically to prevent this kind of issue. And they've done a little bit here, but pretty much the absolute bare minimum. It's like they were told to do it, and they did absolutely the bare minimum, which is not surprising because the Ender 3 is a really ridiculously cheap 3D printer. That produces reasonable quality prints. Right, so last but not least, there's a sticker there that has a screw under it and under here. So if this repair doesn't work, they're not going to be able to claim that it wasn't messed with. So, if we're lucky, that'll come out. Like that. So the big unknown is, did this damage anything else whilst it was rattling around? And it doesn't look like anything's too badly mangled. It's all pretty, yeah, I mean there's lots of space in here. The fact that that's on an angle is a bit weird. So, what, oh, those heat sinks. Right, so the problem is these solders here. Which way around did it go? Probably went that way, possibly that way. That's how it would have gone. So that one's okay. And this one's perhaps a wee bit short, which is why it came loose. And the fact that it had no of this white goop holding it down is suboptimal. Okay, so I've just resoldered them using my 40-watt soldering iron. Held it on there for a reasonable amount of time to give it plenty of heat, so that it definitely joins. It's a single-sided PCB, so there's no vias. It's got to attach to this plane and that's the only option. So next, I probably should have glued it in first and then soldered, but I want to use a hot glue gun, and if I glue it first and then solder, the soldering will melt the hot glue. Otherwise I could use a bunch of silicone. Now that it's soldered in, I might just try the silicone. It takes ages to dry, but it is a bit more heat resistant than the heat gun, naturally. So I definitely should have done this before soldering. So that was all very stupid. Alright, going to do the finger. Bung that in there. Bung that in there. Get a bit more in there. And on the bottom, I'm going to do a bit in there as well. And hopefully that will solve the problem. Alright, so that's messy, but should achieve the desired goal of making sure that doesn't come loose ever again. Right. Now I might as well plug it in and we'll see if it works. We'll either get some voltage or not. Okay. Let's voltmeter, volts. That, try not to electrocute myself. So that there. There's some mains floating around in here. So I'm about ready. I'll put some gloves on so that if I slip I'm not going to accidentally touch something that is 240 volts mains, because that would be bad. Power. Let's put some power in here. It's turned off at the mains. Goes like that. Then I'm going to stick that in there and that in there. That should be 24 volts. Let's turn the mains on. Actually, first of all, I'll stand back and turn it on and see if anything blows up. Stand. I don't want that. Right. Let's get ourselves a wee bit more organised. Okay. I'm just going to make sure the output is well away from the input. That would be bad if those two shorted. So, okay, gloves, mains. Mains is on, ready to turn on, and we'll see if it blows up. Nothing so far. There's a green LED, which is encouraging. It's not making any noise, so that's encouraging. Let's see if we got 24 volts. Woohoo! Alright, mission accomplished. Okay, I need to turn off before those overheat, because there's no heatsink on them. And that, so far, is a success. Now I've got to get it all back in the box and test it again. But that's nice. So that's pretty much what I expected. When one of these comes floating loose, it's just because it wasn't adequately stuck down, which is the classic thing that cheap electronics will try and save time and money on. That all makes sense. To skimp on the time-consuming bits, like gluing things down. What a drag that is. Is that? So there's. Now, this is always the fiddly bit, getting all this bit together. So that is okay, that is okay. I wonder if I should actually attach these before I put them back on the... I should do it this way. No, I can't do it that way. Yeah, I have to do everything at once. That's why it's fiddly. Okay. That's good. Now there's potential for there still to be charge in those capacitors, so I should try to avoid touching anything with my bare fingers. But it's pretty damn hard to do anything without using your fingers. Right, here we go. That's good. Now, before I tighten that up, I've got to get this other one lined up as well. Now, is it? Okay. I think that's all right. That goes in there. Alright, eventually goes in there. Okay, tighten that up. Tighten that up. Is that all going to line up? Mostly. Loosen this off a bit so I can get all this lined up. Good. Good. Okay. So this goes there. Now, look how wonky that socket is. Man, oh man, it's cheap. I put a dab of Scholastic on that in the hopes that that will prevent it popping out and flapping about too much. The other thing that I could do is put some silicone on here to prevent that from flapping about. But it's going to be hard to get in there. I'm not going to be opening this again in a hurry, am I? So I might as well do something now. Should I do something about this? Yeah. Or this. I'm gonna leave it like that. I don't want to tinker too much, or else I'll end up screwing something up. Keep it simple. Get in, do the job, get out. Alright, here we go. So, good. Oh, sheesh. Didn't finish tightening this one. And I don't have any Loctite, which is a bit of a shame. That's good. That's good. Double check. That's tight. That's tight. Okay. That's all good. Why on earth are they using an Allen key at this point? Maybe because the rest of the... I'm guessing the rest of the Ender uses Allen keys. But even so, it's a bit odd. And it's also odd that it only screws in at one side. Alright, so if we test it one more time, mains in, power, mains in, power, volts, turn the power on it before, turn that on. Somewhere inside there's, oh yeah, I can see, okay, oh yeah, there's the little LED, that's encouraging. So let's see what we get here. "24 volts, and if you put it around the right way, 24 volts, fantastic. That looks fixed. So, if you get yourself an Ender, Creality Ender 3 and there's something rattling around inside, that is possibly the problem. Alright, thanks for watching, cheers.